Hey everybody, today we're going to talk about modeling with linear functions. We're going to talk about some words that we've talked about in the past, a regression, correlation, and a line of best fit. So a lot of times when we model with linear functions, we start by making a scatter plot. The scatter plot helps us understand the form, the direction, and the strength of the relationship between the two variables. The correlation is that strength and direction of the linear relationship between the two variables. Now, every time we have a strong linear relationship, we get this thing called a line of best fit. The line of best fit is the one that can be used to kind of best represent all your data points put together. It also can be used to make predictions. Another word for it is a trend line. So every time you have a line of best fit, you also have this thing called a correlation coefficient, and that is an R value. And that tells you how well the data fits your line that you drew, that line of best fit. So there's a couple things you need to understand about the R value. So the R value is called the correlation coefficient. So every kind of line of best fit has a correlation coefficient. And that R value is always between -1 and 1. If it is exactly 1, exactly a positive 1, what that means is that all of the points form a straight line with a positive slope. So your line of best fit would have all of the points land exactly on it. So this would be an R value of +1 because every point would be exactly on that line of best fit. If R is -1, then all of the points are directly on that line, but that line has a negative slope. But if it's exactly -1, that means every point lies on that line of best fit. If your R value is 0, that means the points are all over the place and you cannot tell whether it has a positive or negative correlation, and there really is not a line of best fit to draw. Down below, here are some examples. If you take a look at this, you will quickly see that the R value is negative because it forms a negative slope, or it's like you're walking downhill on that line. Because if I drew a line of best fit, most of the points would lie close to that line or on that line. The R value is very close to -1. It's the same idea when you're drawing a line where you're walking uphill or a line with a positive slope. The R value will be positive and it will be very close to 1 because all of the points almost fall on that line exactly. If you can look at this next example, you can kind of see that the general pattern is that the lines still kind of form a downhill trend like that with a negative slope, but they're certainly not very close to all being on that line. So this R value is negative around 0.6. Same thing if we had a positive R value that was not very high. You can kind of see the general pattern where you're kind of forming that line with a positive slope, but the points do not lie on that line very closely, so the R value is much lower. And then this would be an R value of 0, where the points are all spread out. And there is no real relationship between anything. Now, your calculator will find this R value for you, but you have to put it on. So, when you all get your graphing calculator, if you look down here at the bottom, above the number 0 is the word catalog. So if you all hit your second button and then the catalog, you will see all of these things show up. If you use your down arrow and scroll all the way down, you will eventually come to a word called diagnostic on. Once your arrow is on the diagnostic on, you have to hit enter and then enter again, and that turns your correlation coefficient or your R value on your calculator. All right, so we're going to try one example to start here. It says anthropologists can use the femur, the thigh bone, or the thigh bone to estimate the height of a human being. The table shows the results randomly from a selected sample. Determine whether the data shows a linear relationship by plotting the points and drawing the line. Make a scatter plot of the data with the femur length being the independent. So first thing they tell us is that the femur length is your independent or your X. So down here at the bottom, we are going to put femur length. And along the side, this is going to be our height. So the first thing we have to decide is how we want to label our tick marks. So over here, I'm going to put a little squiggly and I'm going to start around 30. and I'm going to go maybe by twos. 32, 4, 6, 8, 40, 42, 44, 46, 48, 50. On my side, I'm going to start here at about 140, and I'm going to go up for every 2, I'm going to go up by 10. Once I have all those things labeled, I'm then going to plot my points. So at 40, it's all the way up at 170, and I put a dot. At 45, it's at 183. At 32, it's at 151. At 50, it's at 195. 37 is at 162. 41 is at 174. 30 is at 141. 34 is at 151. 47 is at 185. And 45 is at 182. Okay, so from our plot, we can see that it forms a nice, beautiful line. And this line is going to have a positive slope, which means my R value will also be positive. So there's this linear regression feature on our graphing calculator that will help us get the line. So here's how you use your linear regression feature. The first thing you hit is you hit your stat button. And under edit, you just hit enter. And this is where we're going to put in our information. To clear these lists, we go up to L2, hit clear and enter. Go over and up to L1, hit clear and enter. Under L1, we are going to put in our femur length or our X values. Make sure you hit enter in between each X value. Under L2, we are going to put in our Y values. Make sure you hit enter in between each Y value. Once you have entered all the information in, you hit your stat button, over to calculate, and we are trying to find a linear regression line, which is number 4. So you can hit number 4. Everyone's calculators might look a little bit different here, but you have to scroll down and hit enter until you get your linear regression line on your calculator. So our linear regression for this data is y equals my A, which in this case is the slope. I'm going to leave 3 decimal places, 2.604x, and my B is my y-intercept, so plus 64.997. And that is our equation for our line of best fit. So the calculator just took all of those values and calculated the best fit line for that data set. The R value is the number way at the bottom here where it says R equals. It is not R squared, it is what R equals. So our R value here is 0.9945. Because this is really close to 1, that means all of my data points almost fall exactly on that line of best fit. So for this question, it says use your line of best fit to estimate the height of a person whose femur is 41 inches long. Because the femur was my X values, all I'm going to do is I'm going to take my equation and I'm going to plug in the number 41 for X. And that will give me the height in that situation. So my height here is 171.76. And that is in centimeters. Next it says to interpret the slope of the line of best fit in the context of the problem. So our slope here was approximately 2.6. So if you remember, slope is always change in y's over change in x's. If we think about the 2.6 over 1, what that means is that for every 2.6 centimeters in height that you grow, the femur grows 1 centimeter. So for every 2.6 centimeters in height that you grow, your femur bone grows 1 centimeters. Okay, let's try another example. So the next example takes a look at a table. The first question asks what type of function can be used to model the data. If you look at this table, you will see a pattern occurring amongst terms. And if you can't see the pattern, if you take your second term and subtract your first, you will see that you subtract 1250 to go from one to the other. So now if I took 10,750 and minus 1250, I get my next term, so that follows the pattern. If I took that term and subtracted my 1250, I get 8250, which follows the next term. And if I do it one more time and subtract the 1250 again, you will see I will get 7,000. So the pattern here is I'm subtracting that 1250 each time. Because that is the first change and it is a constant increase or decrease, that makes this model going to be a linear model for this data. Let's try again on our calculator to get that regression line. So we're going to go to Stat, Edit, clear your L1 and clear your L2 by highlighting them and hitting Clear and Enter. Under L1, we're going to put all of these values in terms of my year, and under L2, we're going to put the cost. Once I enter in all the information, I go over to Stat, over to Calculate, down to number 4 again. I hit Enter until my equation comes up. So my linear equation is going to be y equals negative 1250x plus 12,000. The last question says, estimate the value of the copy machine in 8 years. Because it's 8 years and years represents my x, all I'm going to do is I'm going to take and plug in 8. And that will give me the value of the copy machine in 8 years. If you flip your page, we are now going to continue on and do the same thing. But instead of showing all of the points this time, we are just going to figure out all of the information. So, one more time, we're going to go, instead of graphing, we're just going to put all of this information in our calculator to get a linear regression line. So if you hit Stat, under Edit, clear your L1 and clear your L2, and I'm going to enter in all of these numbers. In L2, I will enter in all the gas mileage. Once I have all of that information entered in, I go Stat, over to Calculate, down to number 4, and my linear regression line is y equals negative 0.150, if I round correctly, x plus 47.509. The next thing they ask for is the R value to 4 decimal places. In this case, it is negative 0.1961. One thing you will notice is that your slope and your R value will always have the same signs. So if this is negative, that would be negative. If this is positive, that would be positive. So the next question says, use your line of best fit to predict the gas mileage for a 210 horsepower engine. Because horsepower was my x's up here, I'm going to take 210 and plug it in for x. So I have negative 0.150 times 210 plus 47.509. So in this case, that's going to give me 16.009 miles per gallon. Interpret the slope. So again, our slope this time was negative 0.15 over 1. Remember that the top is always your change in y's, and the bottom is always your change in x's. So our change in y's was our mileage, and our change in x's was our horsepower. So what this says is the gas mileage goes down, and it's down because it's negative, 15 cents for every 1 horsepower that you use. And that's our interpretation. All right, if you flip your page one more time, we're going to finish up doing some review of slope and slope-intercept form from Algebra 1A. The first thing you need to remember is the way you get your slope is always y2 minus 1 over x2 minus x1. So you do your change in y's over your change in x's. Okay? So what we're doing then is we're going to get a slope, write an equation, and then interpret the slope again. And we will use that interpretation by using this kind of guide right here. So in our first example, the first thing we are going to do is we are going to call this x1, y1, x2, y2. So I'm going to take y2, 85, minus y1, 95, over x2, 10, minus x1, 20. So I have a slope of negative 10 over negative 10, which just equals a slope of 1. Once you get a slope of 1, if you recall your slope-intercept form for a line, you pick one of the 2 points. I'm going to pick 20, 95. And I plug in 20 for x, 95 for y, and m is my slope of 1. So if I plug in those values, 95 for y, my slope is 1, my x is 20, then I can solve this for b. So I have this 95, 1 times 20 is 20. I subtract that 20, and I get b equal to 75. So my equation is going to be y equals 1x plus 75. So my slope in this case is 1, or 1 over 1. So on top, what this means is for every homework grade percentage of 1, that increases for every 1 assignment I complete. So the easiest way to say that is your math homework grade increases 1% for every assignment completed. And that's your interpretation. All right, let's try the next one. I'm going to start by labeling x1, y1, x2, y2. So y2, 51, minus y1, 50, over x2, 10, minus x1, 0. So I have 1 over 10 as my slope. In this case, we can actually steal the y-intercept from the graph because it gives it to you. Your y-intercept occurs at 50. So we can actually just use that y-intercept instead of having to find it. Over here, we couldn't do that because it didn't give us the y-intercept. So I can automatically go to my equation, y equals 1/10 x plus 50. In this case, my slope is 1 over 10. So the 1 represents your cost in dollars. The 10 represents your number of text messages sent. So what this means is it costs $1 for every 10 text messages sent. And there's your interpretation. Okay, let's try one more, last one. So I have an x1, y1, an x2, y2. I'm going to start with my y2 of 0, minus 360 over 6 minus 0. So I get a negative 360 over 6, which equals a negative 60. Because they again give me my y-intercept, I can just take that. So my equation is y equals negative 60x plus 360. In this case, my slope is negative 60 over 1. So the negative 60 represents the miles I've traveled, and the 1 represents the time. So what this kind of means is you are traveling, this is your travel distance. So your travel distance decreases So it decreases 60 miles for every hour traveled.